Hi everyone. Let me go ahead and close the door. It's loud. Now you didn't sign up for waiting to close the door. You signed up for this video on pre-cal. I'm back. Okay. 3 types of questions that I want to talk about that will mimic the test for tomorrow. So let's start with the easiest one. We did this in class today. So the easiest one is going to be one vector where we need to find the component form, right? So let's say that there is a plane. I want to make sure that I'm doing this right. Hold on. Okay. So let's say we've got a plane. And the plane is traveling on a bearing. Right? Bearing, our favorite word, right? So the plane is on a bearing. And let's say that that bearing is 38 degrees. Fun, right? And let's say that it's traveling at a speed of 150 miles per hour. We want to find the component form of the velocity of that plane. Just worry about component form. Now remember, component form is your XY coordinate of where that plane is going. So the first thing we want to do really is we want to draw the line, because we need to help understand how to change that direction in bearing, which is real world. We need to convert that to a trig ratio or a trig direction. So drawing our picture will help. So remember that bearing starts from the north. Okay, so we're going to start here. So I'm going to go 38 degrees here, right? So now this is probably right. Probably. This is 38 degrees. That's the angle that it opened up to. But the problem is that I need trigonometric form to find the component. And trig form, if you remember, is the magnitude of that vector times the quantity of cosine theta sine theta. Well, this is trig. That's real life. They're 2 completely different worlds. So I need the trig angle. Now remember, bearing starts from the north, but the unit circle starts from the east. So I actually need this angle here. Well, this one's not too bad. If this is 38, what's the difference left over in this 90-degree quadrant? Right, so we'll do 90 minus 38, which is 52. 52 degrees is the trig angle that I'm looking for, or the trig direction. Now, 150 is the speed, which is also magnitude, which is also distance. So this line, I'm gonna erase this 38 for now. This line is 150. So now I have everything I need. I've got the magnitude, which is 150, and I've got the theta, which is 52. So we're gonna plug that in. So I'm gonna have 150 times the quantity of cosine 52 sine 52. We're gonna distribute that out and make sure you're on degrees. We're not gonna be on radians or anything here. So 150 times cosine 52 is 92.3, comma, 150 times sine is 118.2. This is the component form of that vector. So we have our answer, right? So one of these problems is gonna be a bearing problem. We're gonna work this out, okay? Let's go to the next one, because I want to try to keep this video as short as possible. And we're already at 3:44. It's probably not going to be very short. Okay. The next problem is when we have 2 vectors and we have to add them together, right? So there's going to be a lot of information. So let's say that we have a boat. Well, we don't have a boat. I don't have a boat. You might have a boat. It's fine. Right? It's fine. Titan doesn't have a boat, okay? Because he's a dog. So let's say the boat is traveling due north, and it's traveling at 90 miles per hour. It's a nice speedboat, right? Speedboat, okay? The current in the water is, let's say it's north 40 east, okay? And it's traveling at 7 miles per hour. Okay, we want to find the new vector. Right? We want to find the new vector's magnitude and direction. So we need the new vector, or the resultant, we should put resultant, of magnitude and direction. Okay, so we need this. So we've got to draw both of these vectors out. And there's 2 of them because there's 2 different pieces of information. So on the same coordinate plane, we're going to draw both vectors. The boat's going due north, meaning straight up north. Okay. And it's 90 miles per hour. Remember, speed is magnitude is distance. So the distance from the origin to that dot is 90. Okay. Now, we know the component form of that vector. Because if this dot represents 90 up, the component form of the boat is 0, 90. Because that's a point on the coordinate plane, 0, 90, right? And that's great. We need both component forms in order to get to the next step. Now let's do the current. Well, this is a little freaky, right? Because it's a little messed up. North 40 of east, or north 40 degrees from east. So we always start with the second number, or second letter. East is here. I'm going 40 degrees north of here, right? So I'm actually going to open up here, and this is 40 degrees, okay? Now, the beauty of this is because we're in quadrant 1, I don't have to do any conversions because this 40 degrees, which was real world, is the trig value that I need anyway. Now, if I had south 40 east, we would have to do something a little bit different, and I'll do that in a second. But we don't have to do anything different here. And this is 7. So I'm going to erase this 9 here and just move this 90 for a second. This is 7. So this vector, which is the current vector, has a magnitude of 7 and an angle or a direction of 40 degrees. I'm going to use trig form to find the component. So we're going to do 7 times cosine 40, sine 40, okay? And that's going to give me the component form of that vector. So let's do that. 7 times cosine 40 is 5.4, and 7 times sine 40 is 4.5. That's the component of the current. So now I have both. So 5.4, comma 4.5. When you have two vectors, you're going to add them together because we're trying to do the combination of how the boat's traveling and how far off the boat is being pushed by the current, right? Because we need that. So we're going to add the x's together, which is 5.4. We're going to add the y's together, which is 94.5. Okay? So this is where we're going to get our values. Now, if I have my xy coordinate, remember that I need magnitude and direction. Well, I can get both from this. Remember, magnitude is the square root of x squared plus y squared? So we're going to do the square root. How far? Okay. 5.4 squared plus 94.5 squared. And I'm going to do that right now. Sorry, I didn't have this ready. So it's 94.7. So the magnitude is 94.7 on this new vector. Our new vector is a 94.7 distance, or length. And I can use these two values, x, y, to find the direction, which again is inverse tangent of 94.5 divided by 5.4. So we'll do that. And that's 86.73. And that's the degree measurement. Now, I'm okay with that. I'll do a little bit of, or a very quick understanding of what this means in a minute. But remember, if this is the directionality, it's the direction from the north. So this is your answer for now. And I'll just clarify that in the morning. But that's what we're looking at. So here we have our magnitude and we have our direction. Okay. Last problem is a forces problem. If I had, let's say, south 40 east, right? I'm going to start from the east and go 40 degrees south. So this would be the angle, but remember I need trig.
Nathan Hollis, please come to the Gold Gym Lobby desk. Nathan Hollis, please come to the
So I need to go the counterclockwise way.
Thank you.
So if this little chunk was 40, but I have to start from here to go around, the counterclockwise measurement of this would be 320 degrees. Right? Because if I'm starting from here, I'm going 90, 180, 270, and then the half distance from here to here, which is 50. Okay. So if I went south 40 east, this is real world. Trig world is 320. Okay. And we can talk about that again. If you have any questions, let me know on mind. Last type of question is a forces problem. So two forces are centering in on a specific point or an object. And the object, the two forces have an angle in between them, right? So let's say I've got both forces have 65 newtons and 50 newtons of force, right? The angle in between them, let's say, is, I don't know, 160 degrees, okay? We're trying to find the resultant vector in terms of magnitude and direction. So we need the resultant force, which is a vector. I want its magnitude and direction. So a lot of things that are the same from the previous problems. Let's draw this. And we're gonna make ourselves have a nice life here. Doesn't matter really where you put it, right? Use this axis as one of your vectors. Let's just use the 50, who cares? So that's 50. Now I need to open 160 degrees from that line, from this line, because we're starting here. Again, we're starting here because we want to not make a huge deal of the trig to real life ratio. We don't need that. If we start here, we don't need that. So I'm gonna open up 160. So it's gonna be like right here. So this is a 160 degree angle, right? Because if it's 180, it goes to here. And that's gonna be our 65 degree or 65 Newton force. Remember, these are both forces that are both vectors. So now I have everything that I need. I just need to add the vectors together. Well, remember that newtons or force is magnitude, is speed, is distance. So this point, if I'm starting from the origin here to here, is 50, 0. That's the component. Now I don't know the component of this one because we don't count diagonal. We're not allowed to do that. But I have the angle and I have the magnitude. So I'm gonna use trig form. So we're gonna do 65 times cosine 160, sine 160. Okay, and that's gonna give us a value, which is gonna give me our component. So 65 times cosine 160 is negative 61.1. And then 65 times sine 160 is 22.2. I've got both vectors. We're gonna add together, add them down. So 50 plus negative 61 is negative 11.1 and 22.2. This is the resultant vector in component form, but I need magnitude and direction. Well, just like the previous problem, I know what to do. So I'm gonna take this. We are going to do the square root of 11.1 squared plus 22.2 squared. Okay, and that's gonna give us 24.8, which is the magnitude of that vector. Okay. And then we're gonna do the direction. So we're gonna do inverse tangent, 22.2 divided by 11.1, which is gonna give me a direction or a theta measurement of 63.4 degrees. And again, we'll keep that for now. I'll do a little clarifying in the morning, but there we are, right? So the three problems that we did today. First type of problem is a bearing problem. Remember, bearing starts from the north, okay? Second problem is adding vectors. It's gonna be like a boat or a plane.
Joaquin Bell, please come to the Gold Gym lobby.
And then the third problem was two forces acting on an angle, or an acting that makes an angle for the point. Make one of them this part of the x-axis so you can find out what the component form is very easily, because it's 50, 0, all right? Let me know on Remind or an email if you have any questions. See you later.